out, okay, what you understand by acid. Okay, in chemistry, yeah, so I'm not actually doing a science lesson. Okay, it tastes sour and so on. So can you actually tell me, okay, related to chemistry, how do you define acid?
A proton donator.
Again, Josh.
It donates protons.
Okay, so it donates proton, or sometimes people actually take it. Last time they say anything that when it dissolve with water, they give you H plus ion. So H plus is proton. Okay, why H plus is proton, Mr. Gopi? So if you are asking me, yeah. So hydrogen is 1 and 1. Okay, proton is 1. Electron is the same as proton. Neutron is 0. So if H plus, so what happens? The electron went out. So proton is 1, electron went out, 0, neutron is 0. So H plus only has proton. So H plus is proton. Okay, so that is going to be the same. It gives you proton when dissolved in water. Okay, do remember last time they remember this way, yeah? When they are dissolved in water, then we say it gives you H plus, then we say that is acid. Okay, that was the older definition. Okay, but what Josh mentioned just now, the donating proton, is more towards the modern definition, which is more accurate. Okay, donates proton, but not in aqueous. It can be donating proton in any condition. Okay, donating product in any condition, not necessarily must have water. Okay, for example, if I actually put it in HCl, when we write normally, we put HCl is aqueous. And then they will give you H plus and Cl minus, and then we say HCl is going to be acid. Why? It gives you H plus dissolved in water. Yeah, correct. Okay, the older definition. When you look at the definition by Josh, is also correct. Okay, HCl is donating proton. Yeah, it is giving away the proton. Okay, it's still correct. Okay, but what happens, okay, if I have a situation where there is no water that is being involved? Okay, if there is no water being involved, how do I define that? Okay, so that's the problem with the older definition, because I think before I go into that, okay, there is how do we define base? Okay, last time, okay, they define base by saying they give OH minus when dissolved in water. Okay, that's going to be one of the definition. And then they also mentioned that, okay, acid is something that reacts with base. Okay, so it means that, okay, they react with base. So they also say that a base can react with acid, or base is something that can neutralize the acid. So they use that as a definition last time. But the better and modern definition will be, okay, base is something that receives proton. We are not going to look into whether they are going to react with the acid, whether they are going to actually dissolve in water. Okay, no. So this definition that I actually put it in some sort of table or box. Okay, this definition is actually called Bronsted Lorries theory. Now, there are so many other theories, okay, but it's not important. I think when giving H plus, okay, when dissolved in water, that was discovered by a guy called Arrhenius. Okay, Arrhenius is a guy who discovered this way long ago. Yeah, so this one, Bronsted Lorry, I think if you look at the textbook, they have discovered this, not discovered, they proposed this in 1923. Okay, I'm not crazy enough to memorize all the years and so on. I just look at the book. Yeah. So anyway, it's actually a bit modern theory. Yeah. Arrhenius is something that is very, very old. Yeah. So he actually proposed in that way. So of course the theory actually becomes uh, better, okay, to define everything. Why we need a better theory? Okay, so I'll tell you why we need a better theory. Like for example, yes, the theory of saying that HCl is acid is good enough. Okay, when we say that HCl gives you H plus and Cl minus, it's okay, it's good. Okay, it's good also to actually say sodium hydroxide is a base where they are going to actually give you Na plus and OH minus when they are dissolved in water. It's good also. Okay, but how do I actually show that this is going to be acid and base when I have ammonia? Okay, how do I actually show ammonia is a base? Okay, let me actually check with you guys. Justin, is ammonia base or no?
Base, sir.
Yeah. So how do I actually show ammonia as a base?
You can of course. Wait, no. Can react with acid?
Yes. Okay, I think this is actually the older theory. Yeah? So of course you can actually say it will react with the acid to give you NH4 Cl, and this one you can actually rewrite this again by saying that NH4 plus and then Cl minus. Okay, so here you can say it can actually react with the acid. Yeah, react with the acid. So there is a limitation to the theory that is proposed by Arrhenius. Arrhenius said that in order to show it's a base, then it must have OH minus. It's not actually shown over there. Okay, so you actually say a new theory came saying that a base is something that reacts with the acid. But how about like this? NH3 with water, is there going to be a reaction with ammonia and water? Kiara, is there going to be any reaction with ammonia and water? Don't know. Okay, ammonia and water. Okay, ammonia and water, they will actually react. Okay, they will react to give you ammonium ion, ammonium hydroxide actually. Okay, so they will give you this ammonium hydroxide, and this ammonium hydroxide, okay, can be actually written in this form: ammonium ion and then OH minus. So this one is actually when you are using water, I can say that, yeah, the Arrhenius is some kind of correct because, yeah, ammonia, they give you OH minus, but with the presence of water. So the scientists and the chemists, they actually say, can we actually do this without depending on water? Can we actually come up with a theory without depending on water? Okay, so they came up. Okay, they came up with this theory, and this theory is actually can be applied for everything until now. Yeah, so you can see when it's reacting with acid. So I know that ammonia, okay, ammonia is receiving H plus from ACl. Okay, so it is going to receive the proton from the ACl. So I know that this is a proton donor, so this is acid according Bronsted Lorry. And ammonia is receiving the H plus, we call that as base. It's a proton acceptor. Okay, and they will give you this and they will give you this. So this is a better definition. Okay, it's a better definition. Now, since we are doing all this, okay, I have two more questions for you guys. Okay, very important questions that requires you to think, and it's very simple question. Okay, something that we always see every day, but I think we tend to actually forget to ask questions. Okay, the first question is, what is alkali? Can someone actually tell me what is alkali? I'm very sure you know what alkali. Okay, but I'm very sure you heard about alkali, but what is alkali actually?
It's like a base, but like soluble in OH, maybe?
Not soluble in OH, is a base. okay, is a base that is soluble in water. Okay, example of alkali, okay, is sodium hydroxide is an alkali. When you add water, okay, they will give you Na plus and OH minus. They are soluble. Okay, so any base that is soluble in water, they are called alkali. So if I actually have a diagram, a Venn diagram or something like that, okay, if this one is going to be base, all these are going to be base. There are small portion of it, which is going to be the alkali. But not all alkali, it means all alkali is base. Okay, all alkali, they are base, but not all base are alkali. I hope you understand this. Can you give me one example of a base that are not alkaline? So not alkaline means it's a base.
Calcium hydroxide.
Yeah, calcium. Calcium hydroxide, yes, slightly soluble in water. Yeah, okay. Okay, slightly soluble in water because it's supposed to be alkali is completely soluble in water. Calcium hydroxide is one of the base that are not alkali. Generally base, let's say if you look at your periodic table, this side will be basic oxide. Then on the right hand side of your periodic table, they are all acidic oxides somewhere there. So if base, I think maybe group one, all the group one, they are soluble. So probably somewhere from group 2 and group 3. So calcium is going to be one of this. So like, for example, you can actually even say calcium oxide. Calcium oxide, they are not soluble, okay, in water, but it's a base. Okay, and other example, maybe I think just group 2, so MgO, that's another example. Okay, they are something like they are base, but they are not alkali. Other examples will be, I think, the one that we call amphoteric oxide. I hope you remember what is amphoteric oxides. For example, Al2O3, they can react with both acid and base, okay, to give you products, okay. But they themselves, they don't dissolve in water. So they are base, okay, amphoteric oxides, they are base, okay, but they are not actually alkali. Okay, anyway, I'll come back to another question. I told you I have two questions over here. So one is alkali. Another question is, I want to ask, is ammonia alkali? Lindsay?
Yes.
The answer is yes. Ammonia is alkali. Yeah, I think I gave that away just now. Okay, so ammonia can react with water to give you ammonium ion and OH minus. So even though, okay, even though normally we say it's alkali, general way to look at alkali is anything that has OH. Like for example, NaOH is an alkali. Ammonium hydroxide is also alkali. KOH is also alkali. So it's actually quite easy to differentiate. Yeah. Any group 1, group 2, group 1 generally, sodium, potassium, ammonium, okay, all these, especially group 1, yeah, they will give you soluble hydroxide. So when you have that, it's quite easy to determine. But again, when we look at it, like ammonia, or maybe we think ammonia don't have OH behind them. So should I actually include it being an alkali? The answer is yes, okay, because they are soluble in water. Okay, now coming back to, okay, it's already 10, okay, but I want you to actually look at this again. Yeah, this part, okay, let me draw again. do remember we are learning acid-base equilibria. Okay, we are not learning acid and base. Yeah. So do remember, ammonia is a weak base. Okay, anything that is a weak base, they are going to have weak acid, weak base, they are reversible. Okay, so it's part of your reversible reaction. Now, I want you to remember when this thing is happening, when let's say acid and base, do remember that this reaction can happen in both forward and it can also happen in both backwards reaction. So if this is base, this is acid, this base is going to give you something over here. Okay, and this acid is going to give you Cl minus. Now, when this is moving backwards, it means the reaction is moving backwards. What happens is ammonium, okay, if the ammonium want to react, what they will do, they will give away H plus to Cl to give you HCl. Okay, they will give you H plus to Cl to give you HCl over here, and NH3 is going to be formed. It means now, if the backward reaction is happening, this will become acid. But I cannot have this is acid, this is acid. I must have a special name for it. So the special name given is conjugate acid. Okay, so ammonium ion, they are known as conjugate acid. And Cl minus able to receive the H plus, so they are base. What kind of base? I need to differentiate. Okay, so this is called conjugate base. Is that clear? So let's say, for example, if I rewrite this, for example, CH3COOH plus H2O, CH3COO minus plus H3O plus. Okay, which one is the acid over here, Lindsay? Water or ethanoic acid? Forward reaction?
Water.
No, you can see that they are giving the H plus here to give you H3O. Okay, it's a proton donor. So the acid, the ethanoic acid, is going to be the acid here. Water is going to be behaving as a base. Behaving as a base and being a base is different, yeah? Behaving. Okay, why? Because water is receiving the proton. Okay, receiving the proton. Now, when this acid lost the H plus, they are going to give you this. So this one, they will form conjugate. Conjugate what, Jordan? The idea is if you have base, this will become acid. If this is acid, this one will become base. So Jordan, this is acid. So now they will become conjugate base. Okay?
Acid conjugate base.
Yes. So the combination of if this is base, so now this is going to become conjugate acid. This is what I want you to learn today. Okay, the combo. Okay, this is basically what is the important towards the end of the chapter, this part. Yeah, this is important. I will repeat this again. Okay, definitely I'll repeat this again. But we have learned a lot of things today. Okay, take note. Okay, I taught you about the theory. Okay, some theory, but the important theory is the Bronsted Lorries theory. I introduced to you what is base. I introduced to you what is alkali. I also taught you about, okay, in a reversible reaction, acid and base. So how do we find out which one is conjugate acid, which one is conjugate base? Okay, so that's it, guys. Okay, any questions?